Hello everyone, myself Purva Joshi, Assistant Professor at LG Institute of Engineering and Technology. Today we are going to study few more topics of multiple integrals. So let's begin with the first topic, that is change of variable from Cartesian to polar coordinates. The double integral can be changed from Cartesian coordinates xy to polar coordinate r theta by putting x is equals to r cos theta and y is equals to r sin theta. Okay, so whenever we want to change the coordinates from Cartesian to polar coordinate, right? So what we will do, we'll substitute x is equals to r cos theta and y is equals to r sin theta. Okay, so what you will get, double integration f of x y dx dy equals to double integration f of r cos theta comma r sin theta. Here in place of x we have to substitute r cos theta and in place of y r sin theta into mod j dr theta. Okay, where mod j is what it is, a Jacobian, and it is given by del of xy upon del r theta. Okay, and this can be written as del x by del r, del x by del theta, del y by del r, del y by del theta. So whenever we are changing the coordinates, always we have to multiply it by Jacobian. Okay, and here we will solve the Jacobian first. So to solve this del x by del r, okay, means we have to take the derivative of x with respect to r and we have to keep theta constant. So this cos theta is constant, derivative of r is 1, so your answer is cos theta. Okay, then we have to take derivative of x with respect to theta and we have to keep r as a constant. So this r is constant and derivative of cos theta is minus sin theta. Okay, so you will get minus r sin theta. Next, we will find this del y by del r. Okay, means derivative of y with respect to r and we will keep theta constant. Okay, so you will get your answer as sin theta. Okay, and del y by del theta means derivative of y with respect to theta and r is kept constant. Okay, so we know the derivative of sin theta is cos theta, so you will get your answer as r cos theta. Okay, now simplify this. So what you will get, take r common. So from here you will get cos square theta plus sin square theta, and we know cos square theta plus sin square theta is equals to 1. So the answer of this Jacobian is what? R. Right? So this integration, double integration f of xy dx dy is equals to double integration f of r cos theta r sin theta r dr d theta. In place of this Jacobian we have to write r. Okay, so whenever we are converting into polar coordinate, every time we have to take this x as r cos theta and y as r sin theta, right? So you will get Jacobian as r. So every time in place of this dx dy we will write r dr d theta. Okay, so let's begin with the example. Evaluate integration 0 to a 0 to under root a square minus x square plus y square dy dx by changing into polar coordinates. Okay, so we are changing it into polar coordinates. Now here you can see we have x. Okay, so this is our limit of y, right? So limit of y is given, that is y is equals to 0 to y is equals to under root a square minus x square. Now this is the limit of y, so this is our limit of x, right? So limit of x is given, that is x is equals to 0 to x is equals to a, right? So we can say that this x varies from 0 to a, okay, and this y varies from 0 to under root a square minus x square. Okay, now we will simplify this. So take square on both the sides, so you will get y square is equals to a square minus x square. So take this x square here, so you will get x square plus y square is equals to a square, right? Now we have to compare this equation with the equation of circle, that is x minus h whole square plus y minus k whole square is equals to r square, right? So on comparison, you will get the center h comma k as 0 comma 0, right? Because here you can write like this, that is x minus 0 square plus y minus 0 square is equals to a square. Okay, so the center is 0 comma 0 and the radius r is what? A. Okay, next. So this x square plus y square is equals to a square is a circle with center 0 comma 0 and radius r is equals to a. Okay, now we will draw this circle. So the given that x varies from x is equals to 0 to x is equal to a and y varies from y equals to 0 to y equals to under root a square minus x square, right? So from this we have this x square plus y square is equals to a square. Okay, so we have the circle with center at origin and radius a. So here this is a circle with center at origin and radius is a. Okay, now this x is equals to 0 means y axis. Okay, so this is your x is equals to 0. Then x is equals to a will be here, right? Then y is equals to 0 means this x-axis. Okay, now you can see that we have the limit of x from 0 to a, right? So we are considering only first quadrant. Okay, so this is the region of integration. Now we will convert this Cartesian coordinates to polar coordinates. Okay, so from this circle, what we have, this circle when we convert it into polar coordinate, we have the circle r is equals to a. Okay, and we have to draw this a radius vector. Okay, so this radius vector starts from r is equals to 0 and it ends at r is equals to a. So we can say that the limits of r are what? R is equals to 0 to r is equals to a. Okay, and the limit of theta. So the limit of theta goes from 0 to pi by 2, right? So the limits of theta are theta is equals to 0 to theta is equals to pi by 2. Okay. Now the integration given in the question is I is equal to double integration 0 to a 0 to under root a square minus x square plus y square dx dy. Now we will convert everything into polar coordinates. So what you will get? Limits of theta, that is 0 to pi by 2, limits of r 0 to a, and we know this x square plus y square is equals to r square. Why? Because x is equals to r cos theta and y is equals to r sin theta. Okay, so just add them and square it. Okay, so what you will get? X square plus y square as r square cos square theta plus r square sin square theta, right? Take r square common, cos square plus sin square is equals to 1. Okay, so we have r square here. And in place of dx dy, what we have to write? R dr d theta. This r is what? This is a Jacobian. Okay, so on simplification here we have r cube. Okay, now we will integrate this r cube with respect to r and we will keep theta constant. So what you will get? Integration 0 to pi by 2. Integration of r cube is what? R raised to 4 upon 4 and the limits are 0 to a d theta. Substitute the limit. So what you will get? A raised to 4 upon 4. Take out of the integration and here we have integration 0 to pi by 2 d theta. Now the integration of 1 d theta is what? Theta, and the limits are 0 to pi by 2. Substitute the limit, so you will get e raised to 4 upon 4 into pi by 2 minus 0, that is pi by 2. Simplify this, so you will get a raised to 4 pi upon 8. So this is the answer of the integration in polar coordinates. Okay, now we will solve one more example. Evaluate double integration 0 to a y to a x upon x square plus y square dx dy by transforming into polar coordinates. Okay, so again here we are transforming it to polar coordinates. Let's begin with the solution. Here y is given. Okay, so this is the limit of x. So limit of x is given, that is x is equals to y to x is equals to a. And the limits of y is what? 0 to a. y is equals to 0 to y is equals to a. So we can say that this x varies from y to a and y varies from 0 to a. Now putting x is equals to r cos theta and y is equals to r sin theta, we will convert everything into polar form. So you will get from this x is equals to y. Okay, so consider this line y is equals to x. Now in place of y, substitute r sin theta. In place of x, r cos theta. This r will get cancelled. So what will remain? Here tan theta is equals to 1. Okay, bring this cos theta here. So sin theta upon cos theta, that is tan theta, is equals to 1. And from this we can say that the theta is what? Pi by 4. Okay, next. From this line x is equals to a. Now again in place of x substitute r cos theta. So you will get r cos theta is equals to a. So from this you will get r is equals to a sec theta. Bring this cos theta here. So you will get sec theta. Okay. So the r is what? R is equals to a sec theta and theta is what? Pi by 4. Now, so firstly we will draw the graph for this Cartesian coordinate, right? So we have x is equals to y line from here, x is equals to a line from here, right? This y is equals to 0 means this x-axis, and this y is equals to a, it will become here, somewhere here, right? Now this is the region of integration and a horizontal strip is formed. Okay, now what we have to do, we have to convert everything into polar form. So from this x is equals to y, we have theta is equals to pi by 4. So this is the line theta is equals to pi by 4, which is between theta is equals to 0 and pi by 2. So theta is equals to pi by 4 will come exactly at the center, right? And from this line x is equals to a, we have r is equals to a sec theta. And we will draw this radius vector OA here. Now you can see this radius vector starts from r is equals to 0 and it ends at r is equals to a sec theta. So the limits of r are r is equals to 0 to r is equals to a sec theta. Okay, and the limits of theta are theta is equals to 0 to theta is equals to pi by 4. Okay, now we will write the integration given in question, that is I is equal to double integration 0 to a y to a x upon x square plus y square dx dy, right? Now we will convert everything into polar form. So the limits of theta are 0 to pi by 4 and the limits of r 0 to a sec theta. Okay, now we know this x is equals to r cos theta, y is equals to r sin theta. Okay, square plus y square, that is r square cos square theta plus sin square theta, and we know cos square plus sin square is 1, therefore this x square plus y square is what? R square, right? So in place of x square plus y square, just write down r square, and in place of dx dy, what we have to write? R dr d theta. Okay, now this 2r will get cancelled. Okay, and what remains is cos theta dr d theta. Now we will integrate this first with respect to r and then with respect to theta. Okay, so cos theta will remain as it is and integration of 1 dr is what? R, and the limits are 0 to a sec theta d theta, right? Now substitute the limit. So what you will get? Cos theta as it is a sec theta minus 0, that is a sec theta. So we have a sec theta into cos theta, and we know this sec theta into cos theta is 1. So what remains is a we will take outside of the integration. Again we have to integrate this with respect to theta. So you will get here theta and the limits are 0 to pi by 4. Okay, substitute the limit. So you will get answer as a pi by 4. Clear? Now, so in today's session what we have studied, converting the Cartesian coordinates to polar coordinates. Okay, we are converting using this x is equals to r cos theta, y is equals to r sin theta. Okay, so this integration, double integration f of xy dx dy will be equals to double integration over a region R. Okay, so this will be f of r cos theta r sin theta, and in place of dx dy we have mod j dr d theta. Okay, now where j is what? J is Jacobian, that is del xy upon del r theta. Okay, and this we can write as del x by del r, del x by del theta, and del y by del r, del y by del theta. Okay, simplify this so you will get answer as r. Okay, so this integration will convert it to, here we have r dr d theta. Okay, so I hope you have understood throughout the session. Thank you for watching.